Well, it's springtime again, and that means pollen is everywhere. If you're an allergy sufferer, you're probably not a fan. But guess who else might not be too thrilled about pollen in the future? Criminals. Why? Well, there's a growing trend in the field of forensics that's looking to use pollen as a powerful tool in the fight against crime. What does pollen have to do with catching criminals? We'll dive into that and more in today's video on forensic palynology. So what exactly is palynology? In simple terms, it's the study of microscopic organisms and the fragments of organisms like spores and pollen. Scientists prepare samples by using chemicals like hydrofluoric acid to dissolve unwanted compounds like cellulose. The remaining sample is then mounted onto slides and then examined under a light microscope or a scanning electron microscope. But how does this relate to forensics? Well, pollen is actually incredibly useful for uncovering specific details about past events. Pollen is incredibly resilient and it's almost indestructible in many ways. Each type of pollen has its own unique shape and size, and it tends to stick to surfaces, attaching itself to whatever it comes in contact with. This makes pollen a very powerful tool to determine when and where someone has been, since exposure to certain pollen types can be closely tied to certain locations and even times. Think of pollen like a fingerprint. Instead of finding it at a crime scene, though, you find it on an object, giving investigators a trail of where it's been and possibly when. There are some clear benefits to using pollen in forensic investigations. It's ubiquitous, it's found on nearly everything and everywhere, including soil, on people, and even inside products. It's sticky, which means it's easy to find clinging onto things. It's tough enough to last for an indefinite amount of time, and it's invisible to the naked eye, so most criminals would never even know that they're carrying a record of their movements on them. Although it's not yet a common tool in crime scene investigations, there have been several compelling cases in which pollen has helped crack a case wide open. One of the earliest and most notable examples of forensic palynology occurred in Austria in 1959. A man went missing during a trip down the Danube River. They presumed that he was murdered, but no body was found. Authorities had a suspect in custody with a clear motive. They had a suspect, they had a motive, but they didn't have sufficient evidence to convict him. However, they did have one very important clue: a pair of muddy boots. At first glance, muddy boots may not seem very significant, but they ended up being the key to solving the case. Wilhelm Klaus, a palynologist from the University of Vienna, was called in to analyze the mud on the boots. When he examined them, he discovered several different types of pollen. One in particular stood out. It was fossilized hickory pollen from an extinct species that dated back 20 million years to the Miocene era. This, along with pollen from spruce, willow, and alder trees, made a specific combination which could only be found in a small area near Vienna that had those trees and had exposed sediment from that era. In a dramatic moment, reminiscent of a scene from Perry Mason, the suspect was confronted with this information. He realized the jig was up, and he confessed and even led the authorities to the body, which was located precisely where the pollen analysis had indicated. While this was a huge success, forensic palynology has not become a standard tool in criminal investigations. Why is this? If pollen's everywhere, why hasn't it been widely adopted as a CSI tool like DNA analysis? Well, there are a few reasons. First, palynology is not a well-established science, and there are very few trained specialists in the field. This creates a kind of chicken and egg problem. Without enough specialists, it's hard to standardize the science and build the databases that are necessary to make it more applicable. And because it's not widely used, few people will train to become specialists, which makes the cycle continue. Another issue is that palynology has not been widely accepted in forensic science. Without a strong track record in previous court cases or solid data to prove that it works, it's very hard to gain traction. If it's not accepted as valid evidence, it's going to be very unlikely to be used widely, and defense teams will have a very easy time to challenge it as a piece of evidence. This contrasts with DNA, which due to its widespread popularity on crime shows, often has the opposite problem, in which people on the jury assume that its results are always completely accurate or definitive, which is not always the case, because with all forms of testing, it can have limitations and errors. The widespread presence of pollen is also another challenge. It's nice that pollen is everywhere, but that complicates the collection and handling of specimens. Almost anyone or anything that comes into contact with evidence could be a potential source of contamination. This makes collecting uncontaminated pollen samples much harder than collecting something like DNA evidence, especially given the scarcity of trained forensic palynologists. So what does the future hold for forensic palynology? Will it become a valuable tool in solving crimes, or will it remain a niche science only used in rare cases to extract dramatic confessions? Well, only time will tell, but feel free to share your thoughts and predictions in the comments. Thanks for watching all the way till the end. I'm Frank Ciopatini with Cervetti Software, and I'll see you in the next one.